Every long-term user agrees that the best book ever written on Bryce has been Real World Bryce 4 by Susan A. Kitchens and Victor Govender in 2000. They attempted the classic bouncing ball tutorial. It's done in many 3D applications to explain the flow on animation building. It took 19 pages. Not because animation is complicated, but because Bryce doesn't do collision physics automatically, like some other 3D applications. So the lesson here is, avoid simulating collision physics in Bryce. It's not what Bryce does even remotely well. That said, I'm going to do a simple collision physics tutorial. Because I'm insane. Okay, here it is, bouncing a ping pong ball on a bat, and I'm just showing you the ping pong ball bit. Alright, so here's the animation as it stands. Ball travels up and hangs. Kinda weird, but there is method in my madness. Welcome to the Advanced Motion Lab, or AML. It's in 3 sections. The top right's pretty self-evident. Here's where you see your animation in action from either the director or camera's point of view, common transport controls, and buttons that skip forward and back from the timeline you've selected. What's a timeline? It's one of these things on the lower half. The section is the sequencer, or other apps call this the dope sheet, and it's full of timelines. Timelines tell you what objects have keyframes and where they are with respect to time. So here we have the list of objects, and by clicking on the objects we see the parameters associated with that object, and only those timelines that have a keyframe ticker mark set in it. If an object's what we call collapsed, you don't see the ticker marks that indicate the keyframes. If an object's opened, you do. Now, this section gets complicated real quick if you don't select anything before entering the AML, or you select everything before entering the AML, because both of those options lists everything with a set keyframe. A problem that happens a lot is setting redundant or unwanted keyframes, so it's a really good idea to prune this junk out of your timelines with shift deleting. First off, don't get too distracted by the colours. They don't really mean a hell of a lot. Blue is for sky or sun. Let's get rid of the sky. We don't need any sky keyframe in this animation. Delete all keyframes. Yep. The yellow ones seem to be for lights. Greens are for objects. Purples are for meshes. Just get rid of these. Excuse me. And these blue ones are for textures or materials. We'll just get rid of those. Get rid of the plants attached to. And that's looking all neat and easy to understand. Okay, I just have 2 timelines for my ball, position and rotation, because I only set position and rotation keyframes for the ball. How did I do that? Well, you do that by selecting the object and holding down the plus keyframe button until the required object properties come up. If I were to just set a keyframe by selecting and clicking like this, I'd set keyframes for all the ball's parameters. And while this is perfectly fine and generally harmless, keeping the AML clean of timelines reduces confusion. Okay, let's start doing some AML magic. First off, I want the ball oscillating up and down, not held in the air by magic. So the first change is I'm going to set my position timeline to loop in pendulum mode. This plays the timeline sequence forward and then backward from the first keyframe to the last. Okay, so we have linear speed and instantaneous change in velocity at the keyframe points. And it looks unreal because no gravity. Gravity pulls on the ball, meaning it needs to start quickly from the bat, then decelerates to a stop, then accelerates towards the paddle again. That's when we need the time mapping editor, or what I call the acceleration curve editor, or ACE. ACE. Now this is a basic AML orientation. I'm not going to get into all the tricks it has, but at least give you an understanding on it. It's a graph that plots actual time horizontally and apparent time vertically. Now let me show you what that means. You call a parameter's timeline into the ACE by clicking on the parameter in the dope sheet. Ta-da! We're now looking at the default mapping of time for that parameter's keyframes. There are 2 keyframes in this parameter, and they're represented by these dotted lines, and hopefully we can intuitively grasp that this straight line here represents a one-to-one relationship between time actual, that is the time we normally experience in space, and time apparent, which is the time we will distort in our final animation. Okay, your mouse in the ace turns into a magnifying glass. Drag over an area to magnify the curve or line, shift click to zoom out, spacebar drag to move around, and please note, wherever you are, whatever zoom factor, these scales, right, do not update to reflect times. They just stay as they are. Freaks me out, but there you go. Hovering on the line and your cursor turns into a pen, and you can mark extra ace points. So now I've bent linear time into a curve. What does this curve do? Well, you can see what happens in the preview window. Here the ball takes a long actual time while it lingers in the position it would be in apparent time, then races almost instantaneously in actual time to around the final position in apparent time, and then lingers in that apparent time until the end keyframe. Then the pendulum loop kicks in, playing the keyframe sequence backwards. You get that? If you want to play around with acceleration curves, you can choose from these pre-selections up here. Do play around with these curves. They're really good at giving you an understanding on how time actual plots against time apparent. Horizontal lines mean slow, vertical means fast, straight lines mean constant speed. Now I need my ball to simulate gravity, which means plotting a parabola on its side, which looks something like this. And we're done on the position. The rotation is just a finesse wobble as the ball bounces. It's nothing important. I'm going to use this default curve on pendulum, which effectively doubles the speed of the little rotation and smooths out the rotation's reversal. And that's your intro to the AML. Go hard, have fun. It really is time well spent.